Hello, we are going to graph a couple parabolas today. There's actually 3 in our video notes, and this is the situation where we give you an equation and we just tell you to graph the parabola, and you have to know what to do. And I want to tell you that there's a few steps that you can take if you meet these steps. One, it's helpful if you find the roots, because the roots are also the x-intercepts, and they are going to plant your graph onto the axes. And then you can find the vertex and then make a table. And this is going to help you make a smart table that will make your table more efficient. Okay, so we have to find the roots here. Roots means x-intercepts, which means the y value is 0. So what we can do is set the y value equal to 0 and then solve for x. And this is why we've been practicing this all year, is so that we can use our zero product property and our factoring skills to find the vertex. X plus 5 is equal to 0. X minus or plus 5, 7 is equal to 0. During this video, make sure that there's a lot of vocabulary going on. So when you hear me say zero product properties, you annotate zero product property on the side as well. And if I say factoring, annotate that to go from this step to this step, we set 0 to y and we factored. Okay, so x is equal to -5 and x is equal to -7. What this means is that if you put -5 into your equation, you're going to get 0 out. If you put -7 into your equation, you're going to get 0 out. So let's find the vertex. If you missed it in class, if you missed it in class, the x-coordinate of the vertex, and this is a formula. Memorize this because it will make your life easier. X is equal to -b over 2a. This will give you the value of the x-coordinate of your vertex. It'll also give you the line for your axis of symmetry. So that's what you annotate. Also, the line of axis of symmetry. Annotate it next to this. Okay. Let's find the x-coordinate of the vertex. X is, well, we should actually talk about using our standard form. If we have y is equal to x squared plus 12x plus 35, our a value is equal to 1, our b value is equal to 12, and our c value is equal to 35. So this is probably the last time that I'm going to do this, because you will need to know this. Notice it's not 12x. I'm just highlighting the 12. So last time I'm going to do this. A is equal to, B is equal to, and C is equal to. You should be able to recognize that by now. Now we make a table. This is the most important part of the video, because a lot of times when we're having trouble with the graph, we don't know what to do, but you should be able to make a table at the very least. So if you do not know how to graph something, you can make a table. I'm going to make a slightly modified table because I want to show you my steps, but eventually it'll be 2 columns for you. Now, this is how it works. We did all this work to find out, we haven't done it yet, but we need to do all this work to find out what x is equal to -12 over 2, 1. So that's -12 over 2, which is -6. This means that our vertex is at -6. So I'm going to write my -6 in the middle of my t-chart, because then I'm going to go backwards. I'm going to go 3 spaces to the left of -6. If -6 was on a number line, I'm going to go 1, 2, 3, -7, -8, -9, all the way to -7 and -8. I'll go to -8. And then I'm going to go 2 spaces to the right, so -5 and then -4. This is going to help you center your graph so that your graphs are symmetrical. So this is going to be y is equal to ax squared, just x squared plus 12x plus 35. Or in the factored form, sometimes this helps me plug it into the table, x plus 5 and x plus 7. X plus 5 and x plus 7, now we can plug in the x values to get y values. This is how you make a table. This is very helpful in many problem-solving situations. You make a table and it will help you. So I'm going to start with -6. -6 plus 5 times -6 plus 7. If I do this in my head, this is -1 and this is +1, so y is equal to -1. So my vertex is -6, comma, -1. I'm going to do the same thing where I'm going to plug in -7 into my function, and I'm going to see what I get. So this is -2, and then this is 0, so I get 0 for my y value. Okay, I'm going to plug in 8 in my function. Here's 8 here, 8 here. 8 plus 5 is 3, 8 plus 7, oh, this is -8. -8 plus 5 is -3, 8 plus 7 is -8 plus 7 is -1, and multiplied together I get +3. Now I'm going to try this with my other values, plus 5 and plus 7. I'm just going to fill in my formula right now and then plug in my numbers. I'm just doing this so you guys can see how I am plugging in my numbers. I'm taking the function in its factored form. This is what you annotate. I'm taking the function in its factored form, and I am plugging in the x value. All right, so -5 plus 5 is 0. 0 times anything is 0. -4 plus 5 is +1. And -4 plus 7 is +3. So I get a 3 back. Notice how the y values are symmetrical. We have -1, and then we have zeros on both sides. And then we have 3's on both sides. We did that on purpose. So we're going to take these points, our x values and our y values, and plot them on the graph. We're coming back to these, but I'm going to plot them on the graph. Let's plot the vertex first. In your notes, you should write plot the vertex first. Okay, so let's go all the way to -6. 1, 2, 3, 4, 5, 6, and then to -1. So this is my vertex. Then I'm going to plot my other points I have here. -7, 0, and -5, 0. Oh yeah, my roots are at -7 and -5. I even solved for those at the very beginning. And then my last coordinates are -8, comma 3, -8, 1, 2, 3, and then -5, comma 3, 1, 2, 3. The best part of a parabola is drawing in the very swoopy, curvy part and putting these arrows on your parabola. Notice how the arrows are pointing to positive infinity because the range of this parabola is going towards positive infinity. So as you annotate, make sure you put your arrows in there. Sometimes I see people just stop their lines when it gets to here. No, they can continue forever to infinity. Okay, we don't have a lot of time on this video. We're going to graph both a line and a parabola. So on this example number 2, you're going to find the solutions of x squared minus 9 and 2x minus 2y is equal to 6. So we've read the problem. Now let's reread the problem and tear it apart. So find the solutions of solutions. This is where the graphs touch. When this quadratic and this line touch, those are going to be the solutions. And you should probably predict, if you can think in your head some kind of parabola and then some kind of line, there's a few options of how many solutions there are. In this case, there are 2 solutions. In this case, there is 1 solution of a parabola and a line. And then we have the case where there are no solutions. In this case, this graph of this parabola and this line do not have any solutions. So we have 3 options for here. There are 2 solutions to this system, there's 1 solution, or there's no solution. And let's keep tearing this apart. Y equals x squared minus 9. This is going to be a parabola because of the x squared. There's an x squared. It's in the form ax squared plus bx plus c. It's going to be a quadratic. And then this system is a line. And we know that because there is x to the first power. So this first power tells us it's a line, but it's not in slope-intercept form. So it doesn't look very graphable right away. Let's graph the parabola first. So again, we're going to graph the roots, and then we're going to graph the vertex. So the roots of y equals x squared minus 9. Roots are when the y value is 0, so we have x minus 3 and x plus 3. And if we make 2 equations, we have x is equal to 3, x is equal to negative 3. So there are 2 roots that we can plot on the graph right now if we want to. 1, 2, 3. 1, 2, 3. There, our parabola is going to cross those 2 lines. Let's go find the vertex. So we have x is equal to negative b over 2a. Take a look at our quadratic. Our a value is equal to 1. Our b value is equal to, well, there's no b value, so the b value must equal to 0, and our c value is equal to negative 9. So for our vertex, we have x is equal to negative b over 2a. X is going to be 0. So it means our parabola is going to be centered around, it's going to be, the axis of symmetry is on x is equal to 0. Let's graph this. Okay, we have y is equal to x squared minus 9. I'm not factoring in this case because you can either put it in the factored form or the standard form, and you will get the same answers. So I have my x values and my y values. Notice I'm going to start my vertex x coordinate in the middle, and then I'm going to do my math here. 0 squared minus 9 is equal to negative 9. So I already have my vertex, 0, negative 9. Now I'm going to go 2 spaces backwards and 2 spaces forwards. And that's confusing, but I mean 2 spaces to the left of 0. So to the left of 0, if you look on this graph, is negative 1. That's what I mean. Negative 1, negative 2, 1, and 2. And now it's going to be symmetric. Okay, negative 1 squared minus 9 is equal to negative 8. Negative 2 squared minus 9 is equal to negative 5. And then negative 1 squared minus 9 is equal to negative 8. And 2 squared minus 9 is equal to negative 5. So I'm going to plot my points. I have 0, negative 9. So I'm going to plot that first. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I have negative and positive 1, negative 8. Then I have negative 2, negative 5. 1, 2, 3, 4, 5. And it's easy for me to plot because it's symmetric. And I know if I move 2 spaces to the left here, I'm going to move 2 spaces to the right. It's why some people graph parabolas faster than others. Okay, my parabola is going to shoot to positive infinity, and now we need to graph the line to find the solutions. So I'm going to rewrite 2x minus 2y equals 6 as a line in slope-intercept form because I know how to graph lines in slope-intercept form. I'm going to isolate y. And now I have negative 2y, so to undo negative 2y, I'm going to divide by negative 2. So if you need to annotate that in your notes, you're like, I don't know how to isolate y. You need to annotate. It is negative 2 times y. To undo negative 2 times y, divide by negative 2. Okay, so y is equal to negative 2 divided by 2 is positive 1. X. 6 divided by negative 2 is negative 3. So y equals mx plus b. My intercept is negative 3 and my slope is 1. So I'm going to go ahead and graph it. My intercept is negative 3 and my slope is 1. Okay. Oh goodness. I wish I had a ruler on this. Okay, that doesn't answer our questions yet. Finally, on the graph, read off the points where they touch. They touch at 1, 2, 3, 3 comma 0, and they touch at 1, 2, 1, 2, 3, 4, 5. Negative 2, comma, negative 5. So these 2 points are the solutions to this parabola and this line. Go ahead and write your summary. And I would go back in this video and annotate any parts that you still have question marks on or you have caution signs on, and then bring those questions and concerns to class tomorrow. Okay. Bye.